Disease suppressive soils are ones that would fend off diseases before they even had a chance to get into your crop plants. I think this is a worthwhile goal to work towards in regenerative agriculture, but of course, it's not going to be simple and it's not going to cover everything. In this episode, I'm going to go over all of the different ideas that I have seen come up over the years and talk about the plausibility of them. Stay tuned, I will cover this all in this episode. Hi, my name is Scott Gillespie of Plants Dig Soil, the name of the podcast and the consulting company. We're an independent agronomy company. We do not sell products, we provide advice only. We focus on realistic regen ag, which has to be proven and profitable. We work in person or remote or a combination of the two. Our pricing is set to be affordable to anyone from a Q&A package to full farm planning. There's no long-term commitments. You can retain our services, do it yourself, or hire others. Of course, we always love to work with people over the long term. Let's start out with cover crops. I hear often the phrase, get the biology working for you, and it's used in the context of many things. Most of the time, it's in with nutrients, where if you get the biology working for you, they'll just take care of all the nutrients for you. It can also be applied into disease suppression. In the general sense, it would be analogous to being in a crowded street versus an empty street. If you have a bunch of people around, it is safer than being in an empty street where you're not sure what's going on or someone could attack you. I think this is the idea of a general disease defense. You have more biology working in your soil, and the theory is you'll have less chance of it getting into your crop. This does have potential, but it is not a guarantee. And I think it's also something that will build in a system over time as you build up the organisms that work best for you. But as a caution, one time is not going to just take care of all the disease. In fact, it could make some diseases worse, which I have heard some anecdotal evidence of this happening in a farm system. Now, cover crops could be used for specific things, and I will cover this further in the next slide, but it's in this context, a cover crop could be it's usually one species or a few species that target one particular thing. So the problem is that is finding which ones are going to work and getting them to work ahead of the crops that you are planting. And as a caution, like I don't doubt that this could work and that could really help us out, but the research is only just getting going on this, and it needs to be locally adapted because I have seen in a presentation I saw once where a cover crop in Europe was found to be decreasing a disease. It was brought to Canada, and the researchers actually increased the disease in the context. So something about the climate, and probably with the particular organisms or the mix of organisms, had the opposite effect. So just because something works in one area doesn't mean you should just bring it over and expect it to do the same thing. It needs local research to validate. Now, the one system that I have seen that has been very thoroughly tested and and is being implemented by farmers is out of Washington, and it's using a mustard that's high in glucosinolates, which, as far as I understand, these are the chemicals that make it strong to us, and when they're very high, they are they are tough on our bodies and are not good for us to eat. But when they are used in the context of biofumigation, they can have a great effect. So This is where I have heard people talk about putting in cover crops with mustard in it or with brassicas in it, which is the larger family, and they think they're going to get a biofumigation effect. But it only works under very specific circumstances, or at least the circumstances have to be just right for it to do what they're looking for. So this is in the context of potatoes. It takes care of some of the potato diseases. The research and the experience is that it has to get huge biomass. So in Washington, this can be done after a winter crop. So after a regular cash crop, you can grow this in the summer and fall and get this effect. In my area, in Alberta, there wouldn't be enough time to grow this. You would have to take an entire year out of production to do this. That being said, if it gives you more benefit from your potatoes in the following year than you would have got from a cash crop, then by all means, it's a great thing to do. So the specifics are it must be, first of all, the variety that is high in glucosinolates. So there's very specific varieties that work best. It has to grow to 1 to 2 meters high, so you have to get a large biomass. It has to be an early flower, not too far along, but just at its flowering stage. You have to mow it and chop it, and it's very specific. It has to be disked in within an hour, or really within minutes if the disc is following the chopper, because you're actually doing kind of a biohack. You're fumigating the soil with a chemical which is very similar to the commercial synthetic chemicals um, in the soil. So it needs to get in the glucosinolates need to be released, and they change forms within the in the soil rapidly. And for some reason, it seems to kill more of the harmful um, organisms and less of the beneficial ones. So potatoes tend to grow better after it and have less disease. So that is a very intensive system, doing the green manure biofumigant, or trying to grow cover crops in a system, or try to add them in for general or specific impacts. So of course everyone wants to know, is there just something I can put in the soil that um, bypasses all of this? And it's generally referred to as bugs in a jug, and it's because it's every biological seems to have something in it, and it's referred to it as this. So again, there's general and specific. There's ones that have many different things in there, and the hope is that something there is going to help your soil or fend off the disease. There are specific ones that are being developed. As far as I have seen, there's nothing commercially successful on this, but if you know of it, please let me know. And as far as I've seen, there's a few different, or well, there's two different ways that it could be formulated. They could be living organisms, which of course make it much tougher to make it work, because you have to keep them alive and get them into the soil. Dead ones are ones where there could be the chemical that they produce that is actually getting put into the soil, or used on the crop to have a similar effect in disease control as a synthetic chemical, except that in this case it's come from a biological source. Now, my perspective on this is that the soil is so vast, and it's going to be so hard to change things in the soil with just a small amount. Usually these are applied at milliliters per acre, or liters per acre, or grams per acre. Very rarely more than that. And when you consider that in soil in the top 6 inches or 15 centimeters has 1,000,000 kilograms of soil, and you're putting in grams or kilograms, it's a huge dilution factor, and the native biology in there is going to quickly overwhelm it. So where I see a lot of these working, or where I see the potential of it is in seed treatments, because it's a very, very tiny amount needed, and what you're putting into the soil, and it can quickly inoculate your seed as it's growing, if it is one that is going to help it. It could go in furrow, so it doesn't have to go on the seed, but just right sprayed in, or dropped into the soil right at near the seed. I think those ones have the potential. Compost teas, I'm still skeptical of them. I think they can work in very specific circumstances, but the caution that I have heard is that you have to be really careful of what you're putting into that, what you're spraying onto your plants or onto your soil. You might have brewed up a pathogen, or in the case of food safety, if you have used manure in your system or in your compost and there's E. coli in there, you might be spraying your vegetables with E. coli, which is going to cause problems when the humans go to eat it. So nobody wants that. And so, um, in my perspective, I think there's potential in this. But for right now, until I see something that has good testing data or has been locally tried in field scale trials, I'm gonna hold off on it. But again, I'm always on the lookout for something that has potential. Now let's talk about amendments. Now this could be manure, compost, or a newer one is called digestate, which comes from bioreactors. It's what's left over after the the microbes break it down and produce the bioenergy. There could even be sewage sludge is also put into this category as amendments. That comes with its own issues with potential of high metals and pharmaceuticals that come from the human sewer systems. But adding these is actually adding organic matter, because we're not talking about grams per acre or kilograms per acre. We're talking about tons per acre usually that are applied of these. Now, there is an idea, or it's put out, like they do bring their own biology into the system, but from what I can understand, again, it's very quickly overtaken by the native biology. So if you think about it, there are going to be specific organisms that come with compost or come with manure, but their purpose or their niche was growing in that particular environment. So they might help to break it down, but once it's broken down into its smaller components or into small particles, then what is in the soil is going to take over. But it can have a big effect in making your soil more resilient by bringing this back into the system. It's bringing carbon, it's bringing nutrients, it's bringing micronutrients, and overall, if you're not bringing a pathogen in, you can highly benefit your soil. Now, there are some pathogens that can make it in potatoes. Powdery scab can come through manure, so you have to be cautious in what you bring in a potato rotation. It's definitely going to be the highest risk if it's brought in right before the potatoes. But even then, these pathogens, they have very resilient resting structures, so they can sit around for a while. So again, it's not something that is just automatically a good fit for the system. You need to think about it before doing it. Now, why I am a big fan of amendments is what I have seen is that in fields that are now, or that were once small divisions, when they were first set up, or when they were created, and now people have taken down fences and made them larger for large equipment. I can see the old the old feed, or the not really the feed lot, but the area where the animals would have spent their winter, or where the manure was, wherever it was closest to the yard, or the areas that were closest to the yard, those little divisions always got more manure. And I see this effect for 5, 10, or sometimes 20 years later, when I look at satellite images of fields. And I have went out and I have soil sampled these separate areas, and they don't show a huge difference in nutrients. Sometimes they'll show higher phosphorus, so that means they had excessive amounts. But in general, they don't have anything very easy to figure out what is going on. There is something with the manure or with the animals that does help with these fields. So, in my perspective, if you're looking for a disease suppressive soil, stick to the basics or stick to the tried and true, which is manure or compost if you can get it out there, cover crops if you can get it out there. The biologicals and the newer stuff, I think we need to evaluate them, but they aren't something that is going to be a miracle cure. Which brings me to my last point, which is proper crop rotations. I've been told if your crop rotation is just two crops, it's not a rotation, it's just a flip-flop. If you're going between corn and soybeans, or say in the prairies, going between canola and wheat, and you're just going back and forth between the two money-making crops, you're going to get disease build up. And there's not a lot you can do about that. Again, if you put pulse crops such as the peas, beans, lentils, even soybeans are in the same family. They're technically not a pulse because we don't eat them directly. But any of those type of ones, they seem to build up disease faster. So having them out at least to a 4 year, maybe even longer, rotation is really going to be the best thing. And I know that this is a challenge because local markets may only take certain crops, or it may be it is very tough to grow, put in the diversity of rotations. But I think you need to look at what you can do and see what can build your soils over the long term. Now, this is where I think cover crops could fit in, but again, as I said, the research is just getting going on this. It could be a way to break up these shorter crop rotations by putting a different plant in there that could have a similar effect as having a long or a full season crop in there. But again, it's in its infancy, but I see the potential. It seems like cereals before and after anything works. So if you can at least break your cereal crops up with 1 year, then they seem to be fine in a shorter rotation. But then that allows you to put canola or peas or some other type of pulse in there on a 4 year rotation or even longer. Now, I know this is challenging to get into grazing or put a green manure year in, but the evidence coming is that it really does help. If you could break up, say, a 4 year rotation with 1 year of green manure or grazing, or add a perennial phase into your rotation where you can put, say, 2 to 3 years of a perennial, that's going to be one of the greatest ways to break up your disease cycle. But again, the economics make it tough for this to work. So there's again, this is what we come up against in agronomy consulting, is that there's the best way to do it, but then the economics sometimes push against it. This shows up in our human health as well. We probably know what the best foods to eat are and the best exercise to do or movement to do, but it may be economics, it may be cost, but it also may be motivation to do what is the best thing rather than what's the easiest thing. So there's no easy answers to it, but putting all of these practices together, we should be able to come up with a disease suppressive soil and work over the long term to make it economically viable for the farm. So I'd welcome any comments or any stuff that you have seen work or things that you are seeing promising. So please get a hold of me. There's links in the show description. If you can't see that, it's Scott, SCOTT, at plantsdigsoil.com, or just go to the website or search out Plants Dig Soil in a browser and you'll find my website. So I will talk to you next time.